Dear students of Vocational Training Diploma on Electrical and Hybrid Vehicles, I am Engineer Mohammed Masad from the University of Jordan, member of EcoCar Committee, under the Erasmus Plus project, which is coordinated by University of Jordan. Still, we in cluster number 5 about basic of electricity and electronics, and we will continue new topics is number 4. Hello and welcome in topic number 4 about automotive electrical circuit of cluster number 5. We will talk about in this lecture, which is the second lecture of topic number 4 about the electrical automotive circuits. And the duration of this lecture will be about 52 minutes, and will cover 2 chapters as we will see in next slide. The main components of electrical automotive circuits is chapter number 2. This chapter will give an introduction about the main automotive electrical switches and automotive electrical relays types, how to be aware, principle of operation and definition. So chapter 2 of this lecture will cover 2 main subjects. First subject about automotive electrical switches. The second subject will be about automotive definition of switches. A switch is an electrical control device which is used to open and close electrical paths automatically or manually to control current flow or change the direction of current in a circuit. Almost all the electrical and electronic systems contain at least one switch, which is used to make the device on or off. Schematic symbols of the switches. A symbol for a normally open NO switch with no connection, normally open. The second symbol is for normally closed NC switch, closed connection. As you will see here, it's a normally open switch in this picture, and this one is normally closed symbol of a switch. So here no current, no connection. This one is closed, there is connection, there is a current go through this connection. The symbol of the switch is like this. It's called push button switch to open or close the electrical poles and throws of switches. What's the meaning of poles? What's the meaning of throws inside the switch? The pole in a switch indicates the number of circuits that one switch can control for one operation of the switch. But the throw indicates the number of contact points, NO, normally open, and NC contacts, normally closed contacts, or how many different output connections. As we see here in this example, we have here a single pole. This one, a single pole, and double throw. So this is throw, and this is a throw. So this throw is for this circuit to operate the load 1, and this throw in this circuit to operate the load number 2. So this is switch that will be discussed later. Next slide. This is called single pole double throw switch. So this switch has one pole and 2 throws. Function of the switch. Most switches are in the normally open condition NO, which means that the circuit connected with the switch is not linked with the power supplies as the switch is open. When the switch is pressed, means normally closed NC, the circuit is closed as shown in the figure. We have here two circuits. First circuit, the switch is in normally condition. The second circuit, the switch is in closed condition. So here the light is on, but here this is an open circuit since the switch is in normally open state, so the light is off. So we have open circuit when the switch is open. So in this case, since the circuit is open, so no current in the circuit to flow to run the light. But in this circuit, the circuit is closed since the switch is closed, and current will flow in the circuit from the power supply. Simple electric circuit with control switch. The figure below shows the symbols of basic components, including the switch. The switch controls the flow of current, as we said before. On the left picture, this picture, it looks like in our life. We have here power source, we have here control switch, we have here a load. So this power source with its current to control the load by switching on off this switch. On the other right side is the circuit diagram of this picture. Okay, we have here a battery, like this battery. We have here a switch. This is a switch. We have here a lamp. This is the lamp. So the switch here in this case is open, normally open. So this is called schematic diagram, but this circuit is called circuit diagram to show the flow of current. This is the flow of current. So the current here is 0 since the switch is open. When the switch is closed, so there is a current flow through this lamp to the negative side of the power supply. Basic function of automotive switches, as shown in the figure, it's a circuit consists of 4 elements. This is the circuit. The first element is a battery. This is the battery with positive and negative terminal. Lamp, this is the lamp. Switch, and wires. This wire and this wire and this wire and this wire. Okay, that connects all the elements in the circuit. A switch, this is switch, is a connection in the circuit, as you see, that control electrical current by connecting or breaking the path of either the positive side of the circuit. This is the positive side of the circuit, or connecting or breaking the negative side of the circuit. This is the negative side of the circuit during the body or frame or chassis of the vehicle to the negative terminal of the battery. Most of application of switches is to control the path of current inside the positive side of the circuit. Most of applications to control the positive side of the circuit, not to the negative part of the circuit. Single pole, single throw switch. This is one kind of switches. It's called single pole, single throw switch. What's the meaning of single pole, single throw switch? Is a basic on-off switch that turns a single circuit on or off. This kind of switch has two terminals, one for the input and one for the output. It has one single pole and one single throw. So this is the action of this switch. This is for one for the input and this single throw for the output. As you see here in this figure, this is the symbol of a switch. We have here single pole and here is a single throw. This is the shape of a switch with two terminals. This is single pole, single throw switch. This is here one input terminal, and we have here one output terminal or one output cell. The second type of switches is called single pole double throw switch. This switch is a type of switches that has only one input terminal but two output terminals. It means it can control two electrical circuits by making or breaking the contacts with two positions as shown in the figure. This figure, as you see here, this is for the single pole double throw switch. We have here one input terminal with single pole. We have here two output terminals. This first terminal, this second terminal. This is throw number one. This is throw number two. This means that there is here a circuit and here also there is another circuit. And this is the shape of the switches, the single pole double throw. Let's look for the images of electrical switches. There is a lot of kind of switches with different shapes. This is called slide switch. It's called macron switch. Also here are different images of switches. It's push pull switch, toggle switch, toggle switch, toggle switch. This is on off switch. This is push button switch. So we see here different kinds. It depends on the applications of these switches in the circuits or in the systems. Also images of automotive switches. This is door lock switch. This door switch. This is fog switch with indication lamp. This is a car light switch. This is master power control switch to control the doors, on off of the doors, to open and close the windows of the vehicles, also to center lock of the doors, and here also for mirrors, for the lights, for everything in the car by the drivers. Here also to control the air conditioning in the vehicle. And here is the auto heat light headlamp switch. Example of single pole, single throw light switch circuit diagram. The figure shows a typical spotlight circuit, how to control the operation of the circuit by using switch contacts to control a higher current circuit to operate the lamps. So we here complete circuit, how to control two lamps with single pole, single throw switch to control this line, which is the hot line, which is the positive, to pin 86 of the cutout or the relay. The other pin is the 85 to connected to the air, and 7-8 terminal connecting to the output, to the loads, and pin number 3 of the cutout is connecting to the fuse box to prevent any damage for the relay or the light with 16 ampere fuse. So it is connected to the positive terminal of the battery. So this is just an example how to use single pole, single throw switch in this circuit to control the current that switch on off the light. Example 2 about using single pole, single throw as fan switch. The figure shows the most basic diagram simple circuits involving one single pole, single throw switch that turns on load. For example, here a fan on or off. When the switch is off, the circuit is broken, the flow of electricity is interrupted, and the fan turns off. So we have here a single pole, single throw switch. We have here fan, 12-volt fan. This is the positive side of the battery. This is the negative side or the ground. So ground connected to the chassis of this switch and goes to the second terminal of the fan, and we have here the positive terminal of the battery goes to this switch with the positive, and when the switch is on, so this one is connected to this part, to this contact, and then the fan is running. So this is an example of using single pole, single throw switch to control one load or one circuit. Let's take another example about horn switch operation by using single pole, single throw switch. The figure shows a typical horn circuit as you see here. How to control the operation of horn. So we have here a horn switch. This is the horn switch. To complete the circuit, this is circuit. To complete the circuit to the ground by closing this switch. So this circuit goes to ground. This circuit consists of a 12-volt battery from this side to the fuse box to this fuse 15 amps with two loads. This load number 1 is the horn, left horn. This is right horn. We have here a switch. This switch is used to close or open only one circuit path and switch on only one device such as horn in vehicles. So this switch is just only used to switch on off the horn. So we have here one circuit to be connected to the this cutout, this relay during the switching on off of the horn switch. So the current is complete in this circuit by using this relay contacts to close or open when this coil is energized. So when this coil is energized, this coil energized when the positive 12 volt is coming to this point of the coil during the fuse, and when the ground, when the switch is closed, goes to the other part of the coil. In this case, we have here ground, we have here positive 12 volt, so the coil is energized. When this coil is energized, the switch is closed. When this switch is closed, so there is a loop for the 12 volt to the current goes to the loads, to the horn. So the horn is switched on. When the switch is off, so we have here open loop. So in this case, the coil is energized. So this is closed, is open. So there is no path for the 12 volt to the horn. So the horn is off. So this is how to use horn switch, single pole, single throw switch to operate the circuit that has two horns, two loads. Example 4 about the ignition switch, which is very important in the vehicles, and this ignition switch is used for switching on and off of the ignition systems as shown in the figure. This figure, which is used to distribute the high voltage from the ignition coil, also or sometimes called step-up transformer, to the spark plug. So this ignition switch used to switch on the current from the positive terminal of the DC source to the other side. The switch is on to have here a positive electrical current, and we have here electrical ground from this ground, which is the same of the negative terminal of the battery. So in this case, we have here a step-up transformer to transform the low voltage to high voltage to the spark plug when the switch is on. This is the main components of the ignition switch or ignition system. Example 5 about single pole double throw switch. As shown in the figure, single pole double throw switch has one pole and two throws that can influence two circuits, where each circuit connected to the pole. As you see here in this figure, we have here a single pole double throw switch, 4 pins, 1, 2, 3, 4. This is sometimes called rocker switch. This is the schematic diagram of the switch. We have here maximum 10 amps, 12 volt in cars, but in buses, trucks, about 24 operating DC voltage with 10 amps. And also you can see these voltages and currents here on the switch. So in this figure, this is the one pole of the switch, this one, and this is the throw number 1, and this is throw number 2 here. So this switch, by using the positive terminal of the voltage, to the pole number 2. So when this one is closed, so this circuit will goes on, but when this one is closed, the circuit will goes on. So we have here two circuits. This is circuit and this is here a circuit. So this is switch control two load lamps, this one and this one, and sometimes it's called in the vehicles high-low beam. Example 6 about another type of automotive electrical switches, which is called double pole double throw switch, DPDT. Double pole double throw switch is used to control two load paths in vehicles. This is shape of double pole double throw switch. You see here we have 6 pins of the switch. 1, 2, so 1, sorry, 1, 2, 3, 4, 5, 6 pins. So this switch is called double pole double throw switch. The figure now shows a typical lamps circuit. How to control the operation of lamps. This switch is usually used to switch the power supply, which causing the relay contacts to close. So see here, this is double pole double throw switch. This is the 6 pins, 1, 2, 3, 4, 5, 6. So this is the two poles, and here we have, this is the first throw, and this is the second throw. So when the switch is on, so this arm go to this pin, and this arm at the same time go to this pins, in order to throw the current from the positive to the first circuit of lamp, and then goes back in this side to the negative terminal of the battery. And also when this switch goes here, so this is the current from the positive side of the battery goes in this loop to the second circuit and goes back to the negative when this one is closed by this one. So this one goes here to the negative part of the negative terminal of the battery. So this is a circuit using double pole double throw switch. Now let's talk about part number 6 of another kinds of electrical switches, which is called control relays. What's the meaning of commutative relay? Automotive relay is basically just a remote magnetic control electrical switch that allows a small amount of current control circuit nearly to control and operate a higher current of load circuit in vehicular applications. The two circuits, which the small and the high current circuits, are magnetically and mechanically linked, but not electrically connected. Relays are the common type of electromechanical relays that are used in all types of vehicles, like trucks, vans, and buses. Construction of a relay. Basically consists of an internal coil which creates a magnetic field that attracts a movable lever and then with change switch contacts when a current flows through it, as shown in this figure. This is a figure or a picture of a relay. This relay has two or more than two contacts. So this contact, and also here is another contact. So it has two contacts. Relay with two contacts, of which one is normally open. So this is the normally open, this one, while other is normally closed. So we have here a normally open relay. The components of the relay is as follows. This is the relay coil. Here is the terminals of the relay. Here is the movable arm with this or connected to this contact. This one is normally a closed contact. This one is normally open contact. Relay terminal identification. A relay consists of a coil at the ends 1 and 2 terminals, which is called control side, and also consists of contacts pin 3, 4, 5 within the load side, as you will see in this picture. So this is the relay. This is contact. This is 1, and this is number 2. There is a coil between these two terminals, while 3 and 4 and 5 the load side. And you see also this symbol 1, 2 the coil, and here's the number 3, 5 and 4 normally open. This is normally closed. So pin 3 and 4 closed, pin 5 and 3 is normally open. So this is the control side, and this side is the load side. Control side, and this one load side. Relay operation. Natural state of relay in the natural state control side of no current, load side of no current. As you see here, this is the natural state of a relay. This side of the control is open, and this is the load circuit or load side also is open. So there is no current here. Here is low current, control high current. operation state of relay produce of magnetic field due to the flow of current in control side. This is the control side. We have here the coil. So when there is the flow of current in control side, there is a magnetic field because this is switch. This is here is open, and now the switch is closed. So now the contact is closed. So there is a current inside load to control the lamp or load is here. So relay now is on and load is in operation state. So here is a low current. We have here high current on the control, so in the load side. Now let's take an example about relay operation, especially in vehicles. The figure now shows a typical horn circuit, how to control the operation of loads such as two horns by using a 3 pins relay. So we have here two loads, left horn and right horn. These two horn consumes 2 amps. We have here a 12-volt supply to the fuse box, especially to the this fuse, in order to pass the current to the terminal number 2 of the relay. So we have here the 3 pins of the relays. So the small current flow through the coil from this 12-volt battery. So relay creates a magnetic field which attracts this lever and changes the switch contacts to control high current circuit to operate the horns. So when this coil creates magnetic field to attract this arm to close this switch, also it needs a negative ground here from this ground when the horn switch is closed. So in this case we have here positive on the battery, we have here negative from the negative part of the battery. So this coil creates magnetic field to close this switch, and then the current pass through terminal 3 to the 2 horns. So we have here low current control high load circuits that consumes nearly 2 amps, which is the consuming current of the 2 horns. So current switch complete the low current circuit, to ground, causing the relay contacts to close. Relay parts and symbol. A relay consists of a coil, magnetic winding, which is called control side, and load side with contacts terminals as shown in the figure. So we have here the two parts of the control side, which is between this terminal and this terminal, the coil, and the other side is called load side, between these two terminals, normally open and normally closed with this common terminal. So these normally open, normally closed common terminals, as we see here in this symbol, we have here load side, we have here control side. The control side here we have three terminals. COM is the moving part of the switch, and NC is normally closed with common connected to this pin, and the relay coil here is on. When the relay is on, it is closed. But the other terminal, normally open, is connected to the common when the relay is off. Wiring diagram of normally open relay. As shown in the figure, it's normally open 4 pins relay diagram which has 4 terminals as shown. So we have here 4 terminals or 4 pins. This is the coil control side, and this is the load side. This is normally open, so that the coil is between 2 pins 85, 86, as you see here in this shape of the relay. It's 12 volt 40 amps. Here is the control side, the coil side, 85, 86 pins, and the load sides or contact sides, pins 30 and 78. 85, negative coil terminal, this one. 86, this one. Positive low current coil terminal. 87, power output high current, normally open terminal. This one, 87, 87. And 30, high current common terminal. So this is the common terminal of the relay, and also this one here. Another type of relays, which is called normally closed relay. The wiring diagram of this kind of relay, as shown in the figure, is normally closed for relay diagram, which has 4 terminals as follows. This is the 4 relays, 4 terminal relays. We have here, it is closed. The contact is closed between pin 30 and 70 and 87, and the coil is between terminal 85 and 86. This is the shape of this kind of relay. Still, it is 12 volt DC, 40 amps. So this is kind of automotive relays working on the battery of the vehicles. The contact between 87 and 30 is closed, and this is the shape of the coil between 85 and 86 terminals. This is normally closed relay diagram. 85 still negative coil terminal, and 86 positive low current coil terminal. 87 high current normally closed terminal contact, which is closed here, and 30 is high current common terminal. Types of 4 pins relay. There are 2 types of 4 pins relay, normally open and normally closed, as shown below, and also we discussed this information last slide. Here is open relay. This is normally open relay when the coil is non-energized, the contact still open between pin 2 and 4, for example. and when the coil is energized, the contact closed. But this kind of relay, it is a normally closed relay, so the contact is closed between these two pins. When the coil is non-energized, the contact still closed, and when the coil is energized, the contact open. So this relay is opposite of this relay in operation. It depends on the application of the relays. Automotive relay operation, 4 pins. A view of a typical 4-terminal relay as shown in this picture. You have here 4 pins relay. This is 4 terminals, 85, 86, which are the coil terminals. And you have here the positive, and we have here the negative. And the contacts is between 30 and 87, between this one and this one. And normally, in most cases, 85 is the negative and 86 is the positive from the switch. 30 is connected to a power supply or power source, and 87 is connecting to the load, or as also you can connect it in another circuit to control this device or the load. If you applied here a voltage, depends on the relay, for example 12 volt DC. If we applied here, this coil is energized, and this armature of the 30 pin will close to 87. So we can test this relay is okay or not and apply the voltage here. So, and we can measure the resistance between pin or terminal 30 and 86. It will be zero, nearly zero. And if we could disconnect the power source on this side, so the resistance between 30 and 87 is very, very high, infinity, for example. So current flowing through the coil 85, 86, causes the movable arm to be drawn toward the coil magnet. So this one is closed. The contact points complete the electrical circuit connected to terminals 30 and 87, as we said, to control the device on the load circuit. Changeover relay operation 5 pins. The last slides we are talking about operation of 4 pins, and now about 5 pins. Changeover relay is one of the most common type of automotive relay. This relay has the standard 5 pins and can be wired according to the following. This is the shape of the 5 pins relay, as you see here. 85, 86 the coil, and 30 and 87A, 87 the contacts. And this is the wiring inside the relay. 30 and 70, 87A is normally closed, and 30 and 87 normally open, and this is the coil. Normally open using pins 30 and 87, normally closed using pins 30 and 87A, or wired as a changeover, both normally open and normally closed using pin 3 and both pins 87A to change between this one and this one depends on the applications in the automotive circuits. Relay pin configuration. Relays are available with different pin configurations: 3 pins, 4 pins, and 5 pins. Some of the relays are normally open type and the other is normally closed in C. As you see here, this is a relay with 3 pins. This is the coil, this is the contact. This is 4 pins, coil and contact. This is relay with 5 pins. This is the coil, this is the contact, normally closed, normally open. We have type of 5-pin micro relay and 4-pin micro relay with the following shape. This is in the shape of relay. We have here a coil between 1 and 2, 1 and 2, and the contacts between 4, 3, and 5. 3, 5, and okay. And also there is another one, 4 micro relays. This is the coil and this is the contacts. What about the other, which is called N relays? This is with 4 pins, it's with 5 pins. This is here also the coil with 2 contacts, and this is also the coil with 5 terminals. So it depends on the applications. We can see many kinds of automotive relays in the vehicles, maybe like this shape, or like this shape. Depends on the applications and the wattage of the relay. This is the last slide about automotive electrical relays, where we can find the relays in the vehicles. Relays are located through the entire vehicle, and they are located commonly in the engine compartment and under the dash, as shown in the figure. This is the figure where we can find the relays. We have here many relays, as you see in the fuse box, and relays in the vehicles. This is the relays, and this is the fuses. And these relays can be shown also on the cover. This is the cover of the fuse box. This cover of the fuse box usually label the location and position of each fuse and relays. As an example, this relay is for ABS, this relay for ABS, and this relay, this small one, and this small one, the red one, this is for fan number 2, and this is for fan number 3. These are references. You can visit it as links to get more information about the automotive control devices in the vehicles, such as switches and automotive relays. Thank you for your attention, my students, and thank you again. Any questions, you are welcome.